If speed V, area A, and force F are chosen as fundamental units, then the dimensions of Young's modulus will be. In order to find the dimension of Young's modulus, we have to relate it to all these quantities. Yes. What do we know about Young's modulus? Young's modulus, represented by Y, is defined as stress upon strain. Okay. So if I just talk about the dimensional formula of Young's modulus, it would be the dimensional formula of stress upon the dimensional formula of strain, isn't it? What is the dimensional formula of strain, by the way? Strain, which is defined as a change in length upon original length. So if you write the dimension of strain, it's going to be length is represented by L upon L. So it's 1 basically. Yeah. Strain has a dimension 1. So now from here you can say that the dimension of Young's modulus is same as the dimension of stress. Is it not? Okay. Now what is stress? Stress is force per unit area. That's what is stress. That's how we define stress, right? So from here, it's very easy to find the dimension of Young's modulus, isn't it? So let's do that quickly. We know the dimension of force is mlt minus 2, and for area, the dimension is length squared. So this gives us ml minus 1 t minus 2. This is the dimension of Young's modulus. Remember this, okay? This is going to help us find the final answer. What was the dimensional formula for Young's modulus? It was ml minus 1 t minus 2. Okay. It's somehow related to V, that is the speed, area, and force. So let me say that Young's modulus is equal to k times V to the power alpha, area to the power beta, and force to the power gamma. If I can find the values of alpha, beta, and gamma, I'm sorted, isn't it? Okay. This is how Young's modulus is related to these three quantities. What can you say about the dimensions? So dimension of Young's modulus would be equal to the dimension of velocity or speed to the power alpha, area to the power beta, and force to the power gamma. Yeah. K I have ignored because this is a constant, its dimension is 1. So I've ignored that. Okay. Now this, we know the dimension of Young's modulus is this. So I'm just going to substitute it here. ml minus 1 t minus 2. This is equal to, speed is meter per second, so lt minus 1. This thing to the power alpha. Area is meter square or length square, so length square, this thing is raised to the power beta. Force, we know it's mlt minus 2. This thing is raised to the power gamma. We just have to match the powers of m, l, t on either side of this equal to sign, and we'll have our answers. One more step of simplification is needed before we can do that. ml minus 1 t minus 2, this is equal to, let's see what is m raised to on this side. M is raised to gamma. What about L? It's alpha plus 2 beta plus gamma. What can you say about t though? It's minus alpha minus 2 gamma. That's what t is. So we have 3 equations and 3 unknowns, alpha, beta, gamma. We can find their values. Directly by looking at this, I can say that gamma must be equal to 1. Why? Because m is raised to the power this. So gamma must be 1. If I know gamma, it's easy to find this, no? So I'll compare the power of time. So by comparing the power of time, I can say that minus 2 is equal to minus alpha minus 2 times gamma. Well, I know gamma is equal to 1. I've just found out. So I'll just substitute that here. Instead of gamma, let me write 1 here. So this gives me alpha is equal to 0. So if I have alpha and I have gamma, can I find out beta? From the third equation. We'll use the third equation, which is this. Alpha plus 2 beta plus gamma is equal to this thing, minus 1. Alpha is 0, so we'll just cancel this out. Gamma is 1, so 2 beta plus 1 equals minus 1. So beta is equal to minus 1, that's minus 2 upon 2, that's minus 1. So beta equals minus 1. So what is the final expression that we have now? We can say that Young's modulus can also be represented as v to the power alpha, means v to the power 0, a to the power beta, area to the power minus 1, a to the power minus 1, and force to the power gamma. That gamma is, we found out this value, no? Gamma is 1. So V0, A minus 1, F1, which of these gives you the answer? Option number D. So this was the proper method of solving these kind of questions. Okay, there are shortcut methods also. I'll talk about those methods in some other video. Okay, but for now, since we are learning this process, this is the method we should follow. All right, let's try one more question, very much related to this. And if you understand this concept, then you would be able to solve this question also. Note that here multiple options are found. Okay, so let's try this out. Sometimes it's convenient to construct a system of units so that all quantities can be expressed in terms of only one physical quantity. Here, that physical quantity is x. So it's a hypothetical system where dimensions of different quantities like position, speed, acceleration, linear momentum, force, etc. are represented in terms of x only. It's just that position is equal to x to the power alpha, whereas speed is x to the power beta, acceleration is x to the power something else, and so on. But everything is represented in terms of only one fundamental quantity, that is x. So that's the situation. What do we have to find out? We have to find out the relation between those indices. Let's look at the first option. The first option talks about alpha, p, and beta. Alpha is here, p is here, and beta is here. So somehow I have to relate position, speed, and acceleration. Let's write whatever we know first. Speed, we know it's position by time, isn't it? Position by time. Now, we know how position is represented in terms of this new fundamental quantity, x. We know how speed is represented, but we don't know how time is represented. So let's first find out how time should be represented in terms of speed and position. We'll use this only. So time, can I write it as position upon speed? And position is x to the power alpha, whereas speed, the dimension of speed is x to the power beta. So we can say that dimension of time is x to the power alpha minus beta. This is going to help us find the other relation. So we just found out that the dimension of time in terms of these quantities is equal to x to the power alpha minus beta. I'm going to just write it as additional information. Okay, let's try to relate acceleration and speed. Acceleration is defined as the rate of change of speed, isn't it? Change in speed upon time. In other words, if I just talk in terms of dimensions, I would say the dimensions of acceleration is equal to dimension of speed upon the dimension of time. Dimension of acceleration, it's given directly in terms of p, it's x to the power p. So I'll write that. Dimension of speed also given x to the power beta. Dimension of time we just found out x to the power alpha minus beta. Okay, so this is what we have. On simplification, this is what we get. X to the power p is equal to x to the power beta minus alpha plus beta. So 2 beta minus alpha. This is what we get. So from here, something is clear. P equals 2 beta minus alpha. That means alpha plus p equals 2 beta. That means option A is correct. Similarly, we relate linear momentum to all these variables. We relate force to all the other variables and see what we are getting. So let's try that. So we've seen that this is definitely correct, this relation. Let's relate linear momentum to these quantities. Linear momentum is equal to mass multiplied by speed. Mass into velocity, that means. If we talk about the dimensions, it's going to be like this. Linear momentum's dimension is given as x to the power q. Speed's dimension, it's also given in the question as x to the power beta. X to the power beta. So from here, we'll find the dimension of mass. This will be step number 1. So the dimension of mass is, I'm going to write it here. The dimension of mass is going to be x to the power q minus beta. Q minus beta. I hope this is clear. Now, what is the dimension of force? We know force is equal to mass into acceleration. All right. So dimension of force would be equal to dimension of mass into dimension of acceleration. Yes. All right. Dimension of force as given in the question is x to the power r. This is equal to dimension of mass. We've just found out x to the power q minus beta. And dimension of acceleration is also given in the question itself, x to the power p. X to the power brackets. And from here, we'll see that it's equal to x to the power q minus beta plus p. Equating the powers on the left hand side and the right hand side, we get r equals q minus beta plus p. Let's see if this matches with any of the options. So every other option relates p, q, r, and beta. What I'm getting is r plus beta is equal to q plus p. P plus q equals r plus beta. This is the option that I got. And what are the other options saying? P minus q plus r equals alpha, p plus... No, this is not correct. This is not correct. A and B. Both these options are correct, since this is a question from the JEE Advanced paper of 2020. And there are multiple options correct. These are the two options that are correct. Okay. I hope you can do such kind of problems now.